Thanks for the intro, Chris. So I'm Hao. I'm a full stack engineer, currently transitioning to AI engineering. And today I'll be presenting ComponentForge. It's an AI-powered system that transforms screenshots to code. So the tagline says it all. What used to take hours of manual work now takes minutes with automation. So before I show you the solution that I built, I want to explain how front-end development looks like today without ComponentForge. So these form components, for example, are the building blocks of every web application, and each one takes hours to build manually, even though it looks pretty like simple. A single button, for example, could have different variants, right? And it could easily take a full workday, if not a few work days, to build a button. Multiply that by 50 to 100 components in a design system, and you're looking at months of developer time. So after all that work, front-end teams still end up with inconsistent APIs. One developer could use on-click, all right? Another developer could use on-press. This lack of standardization means developers waste a lot of time checking documentation just to figure out how to use the components. So picture this. You export a Figma file at 2 p.m. By 2:10 p.m., you have production-ready TypeScript code. 10 minutes, or probably less. How? So GPT-4 Vision extracts the design tokens. And in ComponentForge, I'm also using a group of AI agents to analyze the component requirements in parallel. Hybrid retrieval finds the perfect pattern with a high level of accuracy. And we generate components with props, variants, accessibility, and storybook stories. So the task that used to take many, many hours now could be done in a couple of minutes. So who is this for? It's built for two critical groups in every modern product team. So first, front-end engineers, the developers who are tired of spending hours manually translating designs into code. No more back and forth with designers about whether that padding is 12 or 16 pixels. The AI extracts it precisely every time. Second, design system teams, right? The teams that are responsible for maintaining component libraries across products. So ComponentForge gives you consistency at scale because every component follows the same patterns, uses the same APIs, and implements the same accessibility standards. So when you have 10 developers building 100 components, that consistency really does become pretty critical. So yeah, let me show you how this works. I'll walk through the complete workflow from screenshot to production code. First, I'm going to go ahead and upload a screenshot of button variants. So you can see in this image, there are primary buttons, secondary buttons, outlined buttons, and button sizes. So I'm going to go ahead and press extract tokens. And what is happening right now is GPT-4 Vision analyzes the image and it automatically extracts colors, spacing, typography, border radius. Usually takes about 10 seconds. On this page, I have also included a modal that provides some tips on what makes a good screenshot for high confidence extraction. Um, yeah, in high accuracy systems, I think the human in the loop part is important, as we will see in the latter steps of this workflow. But I think, you know, uh, garbage in, garbage out. So a good screenshot is going to improve the chances of getting a good output from this whole workflow. So yeah, so tokens extracted successfully. We can see that these tokens are extracted along with the uh, confidence scores. There is an opportunity to edit the tokens if needed. So some of these values are fallback values. So I'm going to go ahead and, okay, also it extracted the spacing details as well. And you can see the tokens here. And I'm going to go ahead and move on to the next step. So this second step involves a multi-agent system. Basically, these agents are running in parallel, and they're going to analyze the props the events, the states, and also the accessibility requirements for the button. So for a simple button component like this, it's going to take about 30 to 60 seconds. So more complex components might take a bit longer. So you can see it identified the button as the screenshot as having a button component. So I'm going to go ahead and accept all of the requirements that the agents identified for this particular component. Okay, I'm going to export requirements, button component, 98% confidence, looks pretty good. So the third step, hybrid retrieval, is going to find the best code pattern match. So our system, so in my evaluation, achieved close to 100% accuracy. So it's searching using both semantic similarity and BM25 keyword matching. So here it proposes 3 candidates with confidence scores, and it correctly identifies the button pattern as the top match. And it took about less than a second. So I'm gonna go ahead and select this pattern. So again, there's like a human in the loop throughout the workflow. So final step is code generation. This takes about 30 to 60 seconds. So while this is running, I can show you what we'll expect the output to look like using the code preview in Stack Blitz. So this is an example of a button that is generated using the workflow in ComponentForge. So as you can see, it's pretty well documented. It shows us all of the different variants that we were expecting based on the screenshot. And you can see that in addition to the documentation, yeah, yeah, there's a bunch of uh, yeah, design tokens that were added to the components. Let's see if it's done. Okay, so yeah, so this is what you get if you look at this report. It passed a security checks, accessibility, compliance, type safety, and the generation took about 36 seconds. And here there's an AI observability link that allows you to trace exactly what happened. So if I click on that, so this basically is going to show us the data related to the agent invocation that just happened. Um, Latency, cool. And yeah, so if you scroll down, you see the Stack Blitz preview that we just saw. So I click on that, it's going to take like a minute or two for the container to build. So yeah, it's gonna probably look something like that. Yeah, so in addition to that, you get the generated TypeScript code with all of the design tokens added to the code pattern. Yeah, and we have Storybook documentation as well that documents the different variants of the buttons. And also a quality report with the compilation results. So this generation looks pretty good. And yeah, so yeah, that's the workflow from screenshot to production ready code in under a couple of minutes. I also wanted to add that, yeah, this workflow currently works best for base components like buttons and cards um, and form inputs. It does not work yet for more complex component composition. So you can imagine a modal that has a button in it that has some cards in it. So that would take a lot more engineering work to figure out correctly. It also does not work for full page layouts yet. Again, yeah, that would require a lot of additional engineering work as well. So, so here's the okay, let me go back to the slide. Yeah, so ComponentForge processes screenshots through a 4-stage AI pipeline. We extract design tokens with GPT-v4. We run a couple of specialized agents in parallel to analyze the requirements. We retrieve the patterns using BM25 keyword search with semantic similarity using weighted fusion. And yeah, we generate TypeScript components. And all of these run on a 3-tiered stack. So front end, we have Next.js, back end, Fast API. Docker container. Yeah, and that's it.